there's a block. Read the question. It's like a person running on a plank, or similar to that already what you had idea. That is what your top line. Let me take this as M2. The person here mass of the person, and this surface is smooth. Anyway, this should be rough, then only can walk, no? And its velocity with respect to the wedge is u1. He's asking us to analyze the situation. We know some basic things like what action the friction should act on the person, the resultant friction, like this, and on the wedge, that ur is constant. And what action the wedge will move? What action the wedge should move, left or right?
Right, sir.
The wedge will move like this. The displacement of wedge will be towards right. Now will, and whatever the normal contact here, and it is like this.
Sir, it would be left, no, sir.
No, right, right. It will be right.
Why, sir?
Like a similar to person walking on a plank. The frictional force will make it. So your component of friction will make it. The component of friction will shift the wedge towards right. Yeah.
But there's a component of normal reaction also, no, sir.
The normal reaction has come because the person starts walking. So is there is in this, as he starts walking, no, this F will be more than N. Check it. And this F is a static.
Sir, sir, but F should be less than N, sir. Because mu is less than 1.
I don't know why you are thinking all unnecessary things here. The simple idea is this F is what? First of all, let's check that one. What is this friction? Static or kinetic?
Static, sir.
Okay, fine. So if there's static friction and is moving with a constant speed, no? So therefore, we will balance the weight of the person, m1g sine theta. We will balance m1g sine theta, the friction acting. So very first thing, the friction acting on the person, the friction force acting on man is mg sine theta only. I'll pick up this option. Option B.
Sir, but how did you say the wedge is moving towards right, sir?
Wait, ma, wait. You have to allow teacher to speak little bit. I have to explain, no? I can't do magic directly. Let me explain all the ideas. The person is moving with a constant speed. So what is this? F is a static friction, F equal to m1g sine theta. And you see that all the velocities are constant. So what is N? N should be equal to what? mg cos theta. N should be equal to mg cos theta, m1g cos theta. This is vertical direction along normal direction. Okay, now let's go for this particular thing. So component of F, how much you get? F cos theta. What is F? F equal to m1g, this one. So here, component of friction along x-axis, how much it will be? F cos theta. Then you are going to say m1g sine theta cos theta towards right. This one. component of normal reaction, you check it. N equal to m1g cos theta. Then here m1g, so like a m1g cos theta sin theta. So if you look at these two forces, in fact they're equal, no? Tell me like here, what is this n? And look at this n, what will happen? So component of friction will also act here. Of course, there is no friction here, so this component friction doesn't matter. So look at this n, n is some sort of reaction, no? The person is able to press hard the inclined plane because of friction. So this n is some sort of reaction and this F is action. And we have done many problems in laws of motion where the normal contact will be less than applied force. Go back to the basics what you have learned. Tell me what is the normal contact that is acting between the blocks here? Will be less than F or greater than F? Less than F, no? The same role plays here. Okay, no, so this is about the option B as moving with a constant speed. Okay, let's come for the velocity of the thing. So how the person is moving. So what is the velocity of the wedge? So I'll resolve the velocity of wedge into two directions. One perpendicular to incline, other parallel to incline. So this velocity, how much it will be? This is theta. So V2 sine theta. What about this? V2 cos theta. The person will be in contact with the wedge, no? When it's in motion. So therefore, what should be the relative motion of the person with respect to wedge along the incline? Should be zero. Then what is the velocity of the wedge perpendicular to incline? That should be the velocity of the person. Because how is the velocity of person with respect to wedge along the incline? So therefore, what is the velocity of person with respect to ground perpendicular to incline? Should be V2 sine theta. So I'll come for option A. I'll start from here. The velocity of person with respect to ground perpendicular to incline is how much? V2 sine theta. Because there's no relative motion. Because what is another reason? Because normal contact is non-zero. Is in contact, no? Constraint equation, better say constraint equation. Sir, why you are writing velocity of the person perpendicular to incline V2 sine theta? Constraint equation. Velocity along the common normal must be equal when the normal contact is non-zero and they're moving with a uniform velocity. Then what is the work done by power due to normal contact? I think option A we are in option A. Power due to normal contact on the man. This should be equal to how much? N into V2 sine theta. Okay, so in fact it will be non-zero. You check it. Next, after this, velocity of power due to friction on man is, I'll come for option C. Power due to friction on man. It should be negative or positive first of all. I think we have discussed previous in exam one problem, person walking on a plank.
Positive.
And is not with respect to wedge is saying. Is not saying with respect to wedge, with respect to power due to friction on man is zero. So shall I pick up this? Or it should be non-zero? For this, what is needed? We needed velocity of the person with respect to ground along the incline. how to calculate that. We know velocity of person with respect to incline, and we know velocity of the incline v2 cos theta. I'll go for relative velocity concept. UR plus velocity of the man along the incline. I think I can write some. Shall I write x and y symbols here? Take like this, x and y. So they should be velocity of man along x minus velocity of the inclined plane along the incline, this one. There should be minus of minus. Upward, I'm taking, up the incline, I'm taking positive. This should be equal to how much? Plus V2 cos theta. So this will be UR minus V2 cos theta. This is the velocity of man with respect to ground along the incline. And what is the power by the friction? What should be the power by the friction? So power by the friction on the man should be equal to how much? F into Vmx. I think it's a non-zero, no? Cannot be zero. With respect to incline, it should be zero. Because the foot what happened will not have any displacement at that instant. Static friction is acting. With respect to ground, it should be non-zero. And power due to normal contact force on the wedges. How the displacement of wedge towards right and how the normal contact is acting towards left. I think it's a non-zero, no? And it should be negative, not positive. It should be equal to n into V2 cos of 90 plus theta. Am I right? Because n is acting like this. This is velocity of the wedge. This is a normal contact force acting on the wedge. This is theta. This is theta. Sorry, this is theta. Take like this. What is the angle between normal contact and acting on the wedge and the velocity of the wedge? 90 plus theta. So will it be positive? It will be negative, no? Just some good problem to analyze. Thinking in different things. The velocity of man with respect to ground, there's a different way I'm trying it, because this will be easiest method to analyze the problem, because a theoretical question, he didn't ask numerical. So you should really search for alternative method. And just took help of the basic constraint equation, because the person is in contact with the inclined plane. So therefore, the velocity along common normal must be equal. Go back to laws of motion. That is what I applied here. You can do by other thing, find out the velocity of person with respect to ground, find the velocity of the wedge, then resolve velocity of the person perpendicular incline. It will kill your time. Always search for any other alternatives available. Okay, no, this is some very good application question I'm bringing. A constant horizontal external force acts on the wedge block system so that no relative motion occurs between the blocks and wedge. Find the average